Hi everybody, Professor H here. We are going to take a look at Chapter 4, the first part, Physical Development. We are looking at infancy. So the next 3 videos will be about infancy. I'm going to go ahead and do our screen share and get us onto our PowerPoint. All right, and present. Okay. Alrighty, so as you notice on this screen, we are talking about Chapter 4, Part 1, which is the physical development part. For every stage of life that we look at from here on out, we're going to be examining 3 different components. We're going to take a look at physical development, cognitive development, and social and emotional development. So it will be broken into 3 different sections. Our video today is looking at physical development in infancy. Infancy comes from a Latin word, in meaning not, fant meaning speaking. So basically infancy means not speaking or without speak. So in this lecture, I already told you this stuff. We're going to be looking at physical, cognitive, socio-emotional. This lecture is the physical component. We're going to start off talking about weight in infants. During this period of life, infants grow faster than at any other period of time. Their weight will double in the first 5 months and it triples by the end of the first year. If our child continued to grow at this rate, they would weigh 600 pounds at 4 years old. Babies appear plump. They will lose that baby fat in the first year. So when they're really little and healthy, when they're young infants and healthy, they look very pudgy. And then they steadily grow with weight, so their weight will increase. But as they get older, they will lose some of that body fat. If you can remember back to our last chapter, we learned that when babies are born, that neonate is about 20 inches long at birth. By the end of the first year, our infant will be 30 inches long. And of course, these are averages. Children can be longer than this, shorter than this. These are just your general averages. Height is interesting because it occurs in spurts. When we were talking about weight a moment ago, that weight has a tendency to steadily increase. So this week you'll have a child that weighs, 20, a certain amount of pounds, and then in 2 weeks it's a little bit heavier. In 2 weeks again, it's heavier again. So it kind of goes up steadily. So we have a steady, continuous increase in weight as long as the child remains healthy. Height does not work quite the same way. Height occurs, these growth spurts that create more height occur at about 1 inch per month. A growth spurt can occur so that the child can grow 1/2 to 1 inch just in 1 or 2 days. So it is not continuous. There are 2 key growth patterns talked about in our book. The first one is cephalocaudal principle. That is head to tail growth. This head to tail growth concept is easily seen in our infants. Our infants, first of all, start to be able to move their head a little bit. Pretty soon they can move their arms. They'll gain a little bit more control over their arms. As they start to become more mobile, you'll notice that they have better control over their arms than they do their legs. Their legs, they gain control over at a later time. So the growth goes from head to tail, cephalocaudal. Cephalus meaning head, caudal meaning tail. The second growth principle is proximodistal. Proximodistal means from the inside to the out. So the way that an infant demonstrates this particular growth pattern is that you'll notice that the interior portions, like the baby can kind of move a little bit side to side, they might be able to roll over well before they have coordination of their arms. Before they will be able to move their arms and gain some control over their arms before they gain a lot of control over their hands. So that development occurs from the inside of the body to the outside. It is proximo-distal. And then here's a little note, most babies are plump and have large heads in proportion to their body. And interestingly, if you look at this baby that we have on the screen, you'll see that the head of this baby is about 1/4 of their entire body. In an adult, the head is about 1/8 of the entire body. So the proportions of our infant are very much different than an adult proportions will be. Their head is like giant. All right. The next thing we're going to talk about is teething. The first tooth usually occurs anywhere from 5 to 9 months. Now, there is a lot of variation to this. Some children are even later than 9 months. Some children even get a first tooth before 5 months. But the average range is somewhere between 5 and 9 months. And they start getting their first teeth, which are the 2 in the front, those little incisors. Teething is said to be occurring when the teeth first break through the skin. During this period of development, the baby experiences a lot of pain and discomfort. About this time, about 5 to 9 months, anywhere from 4 months up, the baby is just starting to sleep better at night. And what happens often is the parents are just finally starting to get some rest because they're really tired because this child pretty much never lets them sleep yet. So this baby is starting to sleep through the night, and then all of a sudden, once again, they're starting to wake up in the middle of the night with tooth pain. Relief for the tooth pain can be found, we're going to talk about, I think I have another slide that talks about this, but it can be found in a teething ring, a cold, wet washcloth for them to suck on while you're supervising them, of course. There are also topical medications that you can use. You should always consult your physician, your pediatrician, before using any type of medications for your child. Okay, interestingly, your book also mentions something that I thought was kind of interesting. Back in the medieval period in Europe, 1 in 3 babies died when they were still infants, before their first year of life. One of the reasons that these people thought their babies was dying is they thought that they were dying because of teething. Teething would cause symptoms such as fever and diarrhea, and that is something that does occur oftentimes when a baby is teething. They'll get loose stools, they start running a little bit of a fever. However, these are the same symptoms that you would see with cholera and other diseases that were prevalent in the medieval period. For example, maybe the baby was getting a hold of some contaminated water or poor hygiene that are causing the baby to have a fever and have diarrhea. However, because not a lot was understood at that time, a lot of people believed that babies were dying because of teething. All right, our next section we're going to talk about is brain development. At birth, the brain is 1/4 the size of an adult's brain. And as you know from previous lecture, we have talked about humans having very large skulls and very large brains. A human brain at birth is not as highly developed as a lot of other mammals. If we were to allow the baby to gestate until this brain was a lot larger and more developed, the baby could never be born. A woman could not get that baby out through her pelvis. By age 2, the brain will be approximately 70% the size and weight of an adult brain. During gestation, the brain at about, it starts creating dendrites at about, I think it's about 4 weeks. Let me see. Oh, 7 weeks. Okay, about 7 weeks gestation, the fetus's brain begins to create neurons. I'm sorry, the developing organism starts to create neurons. The neurons continue to reproduce and reproduce and reproduce throughout gestation. What happens next is when the baby is born, they are actually born with more neurons than they will ever use. And I guess I should back up a second because I didn't really explain what a neuron is. We're going to be looking at an image of a neuron pretty soon. A neuron is the specialized type of cell that we have in our brain and in our nervous system. And it relays signals to different brain areas or to our extremities from our brain and from our spinal cord. So a neuron is a specialized cell. And when we are born, we have way more neurons than we're ever going to use. There are different things that occur, or different types of brain growth that occurs. There is something called exuberance. Exuberance is when dendritic connections multiply, and I'll explain that again when we look at the next slide. When I show you what a dendrite is, they're the little antennas or kind of receivers on the end of a neuron, so that when you have more dendrites or exuberance in the dendrites, you have more areas on your neuron that can pick up signals and communicate. So you have better signaling capacity within the brain. Myelination is another thing that occurs. Myelination is when a specialized type of cell wraps around the axons of the neuron and creates something called the myelin sheath. And this helps to increase the speed and efficiency of signaling within the nervous system. And efficiency increases due to synaptic pruning. And we'll talk about this a little bit more in a slide that's coming up when we look at a graph, when we look at a chart. Okay, so here is our neuron. Our neuron consists of a cell body, and this cell body has everything that any other cell has. It has a nucleus in the middle. It has all the other little organelles and things in it. But this is a specialized type of cell, and this specialized cell is designed to send signals to other neurons downstream. So the dendrites that I mentioned earlier are these little branch-like structures that are on the cell body. What happens is an upstream neuron sends a signal, and then it is received by these dendrites. Then an action potential occurs. In other words, enough stimulation occurs within this cell body, within this neuron, to generate a signal that will travel all the way down to the end of our neuron to something called the synapse. The synapse is a small gap between neurons. So between this neuron and the neighboring dendrites that we see here in gray, these don't actually touch. We used to think that neurons would touch one another, just like if you were wiring something up, electronic, you'd have to have one wire touch the other wire for the signal to go through, and that's how we thought it was working in the human brain. However, we now know that there is a very small gap, and this little tiny small gap is called a synapse. The way the signal transfers, we have an electrical signal that goes down the neuron to the synapse, and then the synapse releases a chemical that is picked up by the dendrites of the next neuron. So these neurons have little receptors that pick up that neurotransmitter. That chemical is called a neurotransmitter. They pick that up on the next neuron, And when this neuron gets enough signaling or gets enough stimulation, it will fire its signal down to the next downstream neuron. So this is your basic structure. This is the myelin sheath. These are those specialized cells that insulate. So what happens here is just like when you have a wire with that coating on the outside, it protects that transmission and accelerates the transmission. So what happens here is the signal can just go through here and jump over the gap, go through, jump over the gap, and it moves very quickly down the axon, down this section. So this myelination makes the signals go more quickly through the system. Now, the brain of a human being is not fully myelinated until the mid-20s. So your connections are not fully functioning to maximum capacity until your mid-20s. So this is the graph that I was referring to a little bit earlier, the timing of neurological processes in the brain. This is our prenatal period. So our prenatal period is from 0 to 40 weeks, and then now we're looking at our postnatal period. Neural production is occurring between 7 weeks and the peak. This is the peak of this production right here. So the peak of the production would be between 7 and it looks like about almost 30 weeks. During this period, we're having just mega neurons being created in our brain. So that way when the human is born, they've got all this wiring ready to go, ready to learn stuff, ready to start doing some actions. Now, axon and dendritic sprouting or branching, remember the axon were those little areas that look like trees, the little branches that receive signals from other neurons. So the axon and dendritic sprouting is mostly occurring between 30 weeks and 18 months. So during this period of time, we are seeing a lot of this dendritic branching. So those dendrites start off with very few branches. And then as the infant grows and develops, more and more branching occurs. As learning occurs, as stimulation occurs, neurons that are used create a lot more dendrites. Neurons that are not used do not have that dendritic sprouting or branching occur. Synapse formation is at its peak between this 30 and about 20 months. 30 weeks prenatally to about 20 months after birth in the postnatal period. And this means that those communication, that synapse is how that little gap where one neuron is going to communicate with the next neuron. This is the period where you have a lot more of these synapses formed, meaning that you have, like this neuron here might have had just two other neurons, two synapses where this other neuron can communicate. Now all of a sudden we've got tons of synapses. So this one neuron can talk to just 1,000 other neurons. And then myelination, the peak myelination is occurring from postnatal to about 14 months. However, as you can see by this arrow, myelination is continuing, synapse formation continues, and with learning, you create a lot more synapses. Every time you learn, you're creating more dendrites, you're creating more synapses. And this neural production is also continuing, just not at the high rates that we see in these areas, but they do continue. And like I said, this myelination, you're not going to be done myelinating until your mid-20s, early to mid-20s. And then synaptic pruning. Synaptic pruning starts to occur about 10 years old. And synaptic pruning is kind of important. Remember how I said that you're going to be born with more synapses than you can ever need. Well, because we have a lot of extra synapses in that brain that aren't being used and they're just sitting there getting cobwebs and dust, the system decides to purge that stuff out and get rid of it. So it's kind of a use it or lose it principle. So about 10 years old, those synapses that are not being used are going to be pruned back. Just like you're pruning a tree, you're going to prune back those synapses that are not being used. Interestingly, babies, for example, are born with the ability to pick up any language that they are around. So a baby born anywhere in the world, so if the baby was born in China and then brought over here and raised with an English-speaking family, they would learn to speak English. And so they are not using the synapses or they're not developing new synapses for Chinese speaking. They're not developing synapses for that language, or neurons that maybe could have been used for that language are not being used, so they are being pruned out. Interestingly, babies can recognize, very young babies can recognize primate faces and tell the difference. There was a neat video about lemurs, I can't find it now, where a baby can actually tell the difference between different lemurs, but an older baby cannot. Like by the time they're about 9 months old, they can't do this anymore, but like a 6-month-old baby could tell the difference between those faces. However, unless that baby's being raised by lemurs, it doesn't need any extra neurons that are going to help it recognize primate faces other than the primates that are raising it, which are humans. So those neurons would be pruned back. In addition, if a child is going to learn a second or third language, which is really good if they can learn multiple languages, there's no research to show that there is anything detrimental by raising a child bilingual, trilingual, you know, there's no negative outcome. And the easiest time for them to do that is before they are 10 years old, because once they are 10 years old, they start having synaptic pruning. So these areas that are not used are cut back and pruned. Okay, sorry, I get excited about this stuff. Okay, so brain specialization. The brain is divided into 3 major regions. We're not going to get into a lot of detail about this. We're just going to kind of go over it kind of more generally. The hindbrain and the midbrain mature pretty early. They are kind of, I'll show it to you on the next slide a little bit better. But they are kind of in here, and they are the older parts of the brain. They have a lot to do with our basic biological functions. So those areas of the brain develop more fully a lot more quickly. The forebrain, which has 2 main systems. We have the limbic system, which is this hypothalamus, thalamus, amygdala, hippocampus, has to do with memory, has to do with fear responses, has to do with homeostasis. In other words, knowing when we're hungry, knowing when we're thirsty, knowing when we're warm, cold. The thalamus, which relays information from the world to us, or from us out to different, you know, or out to different body parts. It's a relay center, basically. And then we have the cerebral cortex. The cerebral cortex is this big wrinkly part, the big wrinkly part that makes us uniquely human. All right. So cerebral cortex is far larger in humans than in other animals. The only ones that kind of rival us are whales and dolphins. They have really big cerebral cortex also, but we're not going to go there. This cerebral cortex, which is this wrinkly part, and it's thought that it's really wrinkled because that way it'll all fit in the skull. If you like flattened it all out, it would be like really big, like real big. So it has to be kind of wrinkled to all fit inside your skull. The cerebral cortex is divided into 2 hemispheres. You have a right and a left hemisphere. So we have the one side of your brain here, the other side of your brain. Both of them have basically the same major structures. There are some differences. For example, language. Your language centers, go away, dog. The language center is usually in your left side of your brain. There are situations where it's not, but for the most part. And we'll get into that stuff a little bit later. So these 2 sides are joined by something called the corpus callosum, which is a big fibrous, it's a big fibrous structure that helps send signals back and forth to both sides of the brain. Lateralization is talking about specialization in one hemisphere versus the other hemisphere. And basically the whole brain kind of works together as a unit. There are certain areas that are more important for certain things, but no one area of the brain can completely manage one particular function. The brain has a lot of communication within its parts. All right, these hemispheres are broken up into 4 different lobes. Sorry about that, I got a little distracted. It's crazy in my house here. We have the occipital, temporal, parietal, and frontal lobes. And we'll take a look at those on the next slide. So here we have our frontal lobe up here, which is the highest processes for planning, future, making decisions. Those type of things are taken care of up here in the frontal lobe, very thinking type of things. We have our parietal lobe, which processes bodily sensation. It does a lot of other things, but these are kind of the main things associated with it. The occipital lobe in the back here is where the visual information is processed, and our temporal lobe over here, kind of near our ears, is where our auditory information and language information is mostly processed. Once again, these are the main areas associated with these things. However, we know, for example, that language, yes, we have some language centers here, but we also know when we put somebody in an fMRI machine and have them speak, that there's some other areas that might light up as well when they're speaking. All right, plasticity of the infant brain. Plasticity refers to the brain being somewhat malleable or changeable. Plasticity is important to the infant's brain development. It has to be able to change, grow, and develop as the infant changes, grows, and develops. It also has to be adaptable to overcome damage. A young child can overcome damage to the brain a lot easier than an older person, because a young child, their brain is more plastic, meaning that it is more malleable. So if one area of the brain is damaged, oftentimes another area of the brain can pick up those functions in a young child, where that won't happen so much in an adult. We do know that deprivation, either through having not enough food, not enough stimulation, this type of deprivation in the early years can have permanent effects. So in that infancy period, or infancy and toddlerhood, that type of damage can be permanent. And we're going to look at the Romanian adoption study, and that will help us clarify that a little bit. All right, so sensory deprivation. So this is kind of a horrible natural experiment that occurred, where when basically the fall of communism, when all of a sudden Westerners could go into Romania and some of these other countries, and this is particularly a picture from a Romanian orphanage where a lot of studies were conducted with these kids that came from these orphanages. These children were in an environment where they were very deprived. They were given not enough food, basically no love, very little social interaction. Nobody read a book, nobody spent time with them, nobody nurtured them, nobody made them feel safe and secure. These kids grew up with sensory deprivation, as well as other types of deprivation. And what they found out was that this deprivation had long-lasting effects on these children. They recovered physically. So they grew up to a normal height, they had, they gained the right body weight. Physiologically, they seemed to recover from this deprivation. However, it depended on how old the child was when they were adopted, basically how long they spent in those conditions, as to whether or not they recovered cognitively or socio-emotionally. This graph shows a comparison of the Romanian adoptees' cognitive abilities by the age of adoption. So what happened was a lot of these children were adopted either into Great Britain or Canada. And a big study was done that basically followed these kids for quite some time. This green bar represents the IQ scores, or the cognitive abilities, basically IQ scores, of children who were in a British orphanage that were not raised under these deprived type of conditions where they had sensory deprivation. And the average score, as you can see, was in the kind of average zone. So their IQs were about average, and this was for children that were adopted at around before 6 months of age, 6 months or earlier, basically. At 6 months of age, children from Great Britain orphanages had normal cognition. So their cognitive abilities and IQ were normal. If one of these children from the Romanian orphanages was adopted before they were 6 months old, their scores were very close to the British babies. So in other words, the deprivation, the sensory deprivation that they experienced did not cause long-lasting problems. These bars, I'm sorry, I don't know if I said this before, these bars are representing their cognitive abilities at the age of 6. So they're being tested as 6-year-olds. The children that were adopted from the Romanian orphanages at 6 to 24 months, these children had below average IQs. The sensory deprivation that they experienced tended to be long-lasting, and they did not make it up to the level of those children that were adopted earlier. Children that were even older, from 24 to 42 months, had even lower cognitive scores. So this horrible natural experiment was giving evidence to the idea that sensory deprivation has a very large effect in children over 6 months of age, but that children over under 6 months of age could kind of recover from that. All right, so that just kind of lends to the idea that, you know, that social interaction and that caring environment and that stimulating, cognitively stimulating environment is important. These kids did not have a picture on the wall. They didn't have anything color. Everything was gray. They did not have any stimulation. All right. We're going to now talk about sleeping. If you can remember from our previous lecture, neonates sleep about 16 to 17 hours. By the time they are 3 to 4 months old, they sleep 6 to 7 hours at night, per night. Interestingly, by the time an infant is 6 months old, their culture has a large influence on their sleep patterns. So up to about this almost 6-month period, the way that infants sleep is pretty universal. The amount of sleep they get, their physical development is pretty close. At 6 months, American children get about 14 hours of sleep on average per day. Oftentimes, American kids are put down in their crib to sleep. They're not packed around all the time or carried around all the time. The Kipsigis of Kenya, their time for average sleep was 12 hours for their infants. This is a traditional culture where these moms, basically these children would sleep on average 12 hours, but maybe in shorter intervals because they're strapped on the mom's back or being held by a relative or an older sibling, pretty much held all the time or carried pretty much all the time, mainly for their safety. And they slept about 12 hours because if you're strapped on the mom, you might wake up more. It's just kind of a different deal. And in Dutch society, the average infant gets about 16 hours of sleep. So that's even 2 hours more than American babies. And the cultural impact is due to the value of sleep in Dutch culture, they very much value a good night's sleep, and early bedtimes for children is really big in Dutch society. The next thing we're going to talk about that has to do with sleep is sudden infant death syndrome, or SIDS. Infants between 2 to 4 months of age are at higher risk of SIDS. SIDS is a condition where the baby is basically put down to sleep and they never wake up. They die in their sleep. This is the leading cause of death for infants 1 to 12 months in developed countries. In developed countries, there are some ethnic variations, and these are that Asian children are the least likely statistically to die from sudden infant death syndrome. African American and Native American kids are 6 times higher, have a 6 times higher rate than white children. This is believed to be possibly due to poor prenatal care. Oftentimes, children from the Asian culture are kept with the family member, are kept close with them a lot, and that may be a contributor to them having not as high of rates of SIDS. But with the African American and the Native American in United States, we know that these particular groups often have a barrier when it comes to accessing good prenatal care. So some of these children might be poor birth weight. There are other factors, socioeconomic issues involved with these cultures that could make them have a higher risk of SIDS. There is no clear cause of SIDS. However, there are a few different things, some theories out there. One theory, it talks about a possible form of sleep apnea. Another theory that your book talks about is hypothesizing that there is a difficulty for the child from transferring between reflexive behaviors and intentional behaviors. During the early period, the first couple of months of life, the baby will be able to, if the infant has its face covered or its airway is blocked, there is some reflexive responses. The baby will raise its hands to its face and do this, and that is a reflex. It's not a intentional response, it is a reflexive response. They will move their head back and forth, and they will put their hands to their face, and that is reflexive. However, when that reflex goes away, as many of the reflexes do at a couple of months, 2 to 3 months, a lot of these reflexive behaviors have now dissipated, and now what we have are intentional responses. It is believed that it's possible that the infant has not gained enough coordination to manage this behavior on their own, of getting their hands up or doing that. And one of the recommendations for protecting the infant from SIDS is to make sure the child sleeps on their back. Their risk is a lot higher if they're sleeping on their stomach or on their side. So sleeping on the back has decreased the incidence of SIDS greatly. In addition, don't have stuffed animals, don't have extra bedding, don't have that baby pillow, none of that kind of stuff that a baby could suffocate on. So, risk factors for SIDS: sleeping on the stomach or on their side, because they can tip over to their stomach. Low birth weight babies, because their lungs oftentimes are not working as well and they are not quite as developed. Having a low Apgar scale at birth creates a higher risk. Mothers who smoke or are around a smoker have higher incidence for SIDS. Sleeping in an overheated room is increasing the risk of SIDS. Wearing 2 or more layers of clothing, and most deaths occur in autumn and winter, where oftentimes the child is bundled up really in more than 1 layer of clothes, or the heater's on really high. Soft bedding and sleeping on the sofa are also big risks for SIDS. The impact of prevention campaigns on SIDS rates. All right, if you take a look at this graph, these blue lines are from 1990, and these are the number of deaths per 1,000 live births. So we're talking about the mortality rate for SIDS. So let's see, number per 1,000 per year. As you can see, in 2005, our bars are orange bars, which are significantly lower than our 1990 bars. And what made the difference here? What made that difference and lowered these rates? And these are developed countries that we're looking at. Japan already had the lower rate of SIDS, but theirs even came down even lower. Well, the campaign was that they went out and they put up posters and really worked very hard at letting parents know that a baby needs to sleep on their back. And that campaign of teaching people that the baby needs to sleep on their back and not have all this other stuff around them, mainly the sleeping on the back, is what is attributed to lowering these rates. All right, co-sleeping, helpful or harmful to babies? Now, in the United States, co-sleeping is something that has been warned against. We are an individualistic society, so many people feel that if you let the baby sleep with you, they're going to become excessively dependent, it's going to be bad for their emotional health, and it can increase the risk of SIDS. As far as excessive dependence and emotional health, I don't know about that. But the increased risk of SIDS has been documented when co-sleeping in the United States. And this may be due to the fact that usually the parent is sleeping on a very soft bed, very soft bed, very soft bedding, pillows, things like that, that the baby can roll over and suffocate on. So that could be one reason why those rates are a little bit higher, because these developed countries have high rates of SIDS. Developing countries with more of a traditional way of raising their children don't have high rates of SIDS. SIDS is almost unknown in developing traditional cultures. These cultures have a collectivist view, meaning that they're not valuing individualism. They're valuing this person learning to become a part of the group, a part of the society. A lot of developing countries with traditional cultures and their collectivist cultures, they believe that by having this infant sleep with the mom until the next child is born, and then oftentimes the child will then sleep with the dad or sleep with other siblings, this helps build that sense of community and interdependence upon each other, which is very important in collectivist cultures. These cultures, which are the majority of the world, they believe that the isolation of an infant is cruel, to have it just left in its crib or have it cry it out. Whereas, you know, in American culture, people sometimes say, well, I'm just going to let that baby cry it out. That is thought of as cruel in a lot of these developing countries. Now, these traditional cultures also have the baby sleep with them. And the difference is that these mothers in these traditional cultures are usually laying on a mat. They don't have thick bedding, it's a firm surface. And the baby is placed on its back next to the mom. And that way the mom can easily breastfeed that baby at night without having to get up or disturb anybody. The baby just, you know, just kind of rolls on their side, the baby eats, and the baby's already on its back. And also the other thing that may be a contributing factor, researchers feel that in that type of environment, the baby is being woke up a lot. So the mom will hear the baby moves a lot, and then that also may be a factor in reducing the risk of SIDS. Japan, South Korea, and Taiwan are developed countries, but they also consider co-sleeping as a norm, and they are also collectivist societies. This type of pattern, whether or not it's, against co-sleeping or for co-sleeping, is an example of a custom complex, which is a distinct cultural pattern that underlies a cultural belief. So the collectivist cultures are believing that you should co-sleep, and the individualistic cultures are saying that no, that creates excessive dependence. All right. Moving on to nutrition. During infancy, the child will have a higher need for nutrition than any other time of their life. They are growing really rapidly, as we mentioned earlier. They have a higher need for high-fat foods than any other period of development due to this rapid growth. How good of nutrition the infant gets depends on their cultural, economic, and social context. Solid foods are introduced somewhere around 4 to 6 months in many cultures. And as mentioned before, infants need a high-fat diet that breast milk provides. Around 4 to 6 months, the child will still have a gag reflex. About 6 months is when the child usually starts having an interest in what other people around them are eating, and they'll start looking at somebody who's eating and opening their mouth and things like that. In Western cultures, babies are usually started with a rice cereal mixed with breast milk or formula. And once again, they have that gag reflex until about 6 months. So you take the spoon, you put it in the baby's mouth, and what happens? Most of it just spits right back out. And this goes on for a long time. About 6 months, they start being able to chew a little bit, start to swallow better, but it takes some time for that to develop. In traditional cultures, moms have to mash or pre-chew the food, somehow puree it. Oftentimes, traditional cultures will start introducing foods like mushed up food or pre-chewed foods to the baby in the very first weeks of life. And once again, they have that gag reflex, so they spit a lot of it out. And that variety of what the children are fed in both cultures, in the Western cultures or in traditional cultures, the variety increases as the child gets older. Malnutrition in infancy. I gave you some statistics before about malnutrition in infancy, and that a lot of infants die due to bottle use in developing countries due to contaminated water. Another big problem is malnutrition. Malnutrition in infancy can be severe and enduring, and oftentimes children do not recover from it. Malnutrition can be due to a mother not being able to produce enough breast milk. Maybe she is starved, maybe she is unhealthy and just unable to produce that milk that is needed for the baby. Maybe they do not have access to any type of supplement. For some reason she's unable to eat them, to feed that child. Marasmus is a type of starvation that you'll see with this child here, where the child is simply lacking nutrients. They are malnourished and lack nutrients. Oftentimes, if intervention is brought in and these children are saved, then oftentimes they still have some cognitive problems afterward. All right, and we're going to talk about another type of malnutrition later as well. Sorry. Okay, infant mortality. What causes infants to die? What are the main reasons why infants die? Most infant mortality is neonatal. So most of the deaths of infants occur in that neonatal period, during that first period after birth. And the majority of these deaths occur due to severe birth defects, preterm complications, being born premature, or maternal death. which can also either directly cause the child to die, or the mother might die and there might not be anybody else there who can provide adequate nutrition for the child, and the child dies. The top sources of infant mortality in developing countries is malnutrition, pneumonia. Malnutrition can lead to the child being more susceptible to respiratory ailments like pneumonia or influenza, malaria, and diarrhea. Diarrhea kills many, many children. And we talked about that before. I think it was like 1.5 million a year. And that is due to maybe having bad water mixed with formula. The diarrhea can be oftentimes treated by what's called oral rehydration therapy. I says theory, but I meant therapy. It is like a saline and glucose stuff that is given to the child, and it can help rehydrate them. It's not very expensive, but in a lot of places in the world, they absolutely do not have access to this very simple this very simple treatment that can save lives. Bottle-fed babies in developing countries are 5 times more likely to die. All right, another difference between developing countries and developed countries is the use of vaccinations. Vaccinations have a long history of being very safe. Smallpox has been eliminated from most of the world well, as far as we know, there's no cases of smallpox currently in the world, and that is due to people being vaccinated for smallpox. Polio was almost entirely eliminated, but then there were a few pockets in one area of the world where people didn't want to vaccinate, or they were unable to vaccinate, and so there is still polio in the world, but it is eliminated in most regions of the world. Diphtheria is eliminated in many regions of the world, and these are things that have killed children, like I was talking about in the Middle Ages. You know, these things killed kids. Yellow fever, eliminated in many regions. Tetanus, these are all things that we vaccinate for, and there are other vaccinations as well. In the West, vaccinations were very popular, very common, and most people would get their children vaccinated. And then came along this doctor who put out a paper and published a paper, and this journal was irresponsible for publishing it without checking it out better first. He stated that autism was caused by the use of vaccinations. This is not true. There is no evidence that vaccinations cause autism. The doctor who put out these false claims lost his license. The paper retracted the article and printed a, rebuttal to it or whatever, but it was too late. The damage was done. Once false information is put out there and people just latch onto that, it's hard to have them learn the truth afterward. So unfortunately, we have a lot of people who do not vaccinate their kids, and that's your right as an American, whatever, do your own thing, okay? I'm just saying that if you don't vaccinate a healthy child, then a child who cannot have a vaccination due to some type, they have cancer or some other thing where they cannot withstand a vaccination, then they do not have what we would consider herd immunity, because those people that cannot get it vaccinated, we depend on herd immunity, meaning that the healthy people get the vaccinations and that protects the ones that can't. But, this is one of those things that goes on in the United States. I'm not here to tell you to vaccinate your kid or not vaccinate your kid. I vaccinated mine. That's my personal, thing. I'm all about science. And what it is my duty to do is to tell you that the science says that vaccinations do not cause autism. So that's my word on that. This is just a map about infant mortality rates in the world. We are pretty low. We're in this light yellow range. This is deaths during the first year of life per 1,000 births. So 1 to 9.9 per 1,000. So almost 1 to 10 kids per 1,000 kids that die. Is this light yellow? So we're in the better range of this. And we have our dark red. We have a little place over here in Africa, it looks like. And so anyway, you can just take a look at this on your own. We're not going to go over all that. This is just showing mortality rates worldwide. Cultural beliefs and practices to protect infants. Historically, as I mentioned earlier, people have mistakenly contributed cause to why things are occurring. For example, 1 in 3 babies died in medieval Europe. I mentioned that earlier. It was believed that teething was this cause of death. This is where the confusion of correlation and causation comes in. Correlation was like, oh, there's a relationship. This child is teething, he has a fever, he has diarrhea, and now he died. All right, that's a relationship. However, what was actually killing the children wasn't the teething, it was the cholera or whatever condition that the child had. Because throughout history, infancy has been kind of a delicate time. A lot of babies died before they were 1 year old. There's a lot of things that can kill children. Traditional cultures came up with their own ways to ward off evil spirits or do things to protect these babies. Parents were very aware of the vulnerabilities, and that influenced the practices that were put in place by the cultures. Your book has some wonderful examples if you have a chance to read in there. One culture believed that you had to keep a very sharp knife really close to the baby and where the baby's sleeping at all times to scare off like evil spirits that would want to take them. Another culture believed that you needed to cover that baby anytime that they're outside during the day. They have to be fully covered with rags so that spirits couldn't see them, and you have to sweat them, and you have to bathe them 3 times a day. All these different things that the different cultures have come up with. Some cultures have little amulets that they have to try to protect the babies from harm, and these are ways for humans to try to make sense of all of this and to try to feel like we have a sense of control over what is going on with our infants and the danger that they're in. Okay, moving along. I know this is getting to be a long video. Gross motor development. Gross motor development would include whole body movements like crawling, like the moving of my arm. This is a gross motor skill. Walking is a gross motor skill. Children tend to develop gross motor skills in sequence. So they tend to roll over, sit without support, then stand, then walk. Now it doesn't always work this way. I remember when my niece was here in my living room, it was just before Christmas, or she was here for Christmas, I think, and she just started rolling over and she rolled all the way across my living room. And that's like, she was just a few months old, just rolling across the living room. And that's when she first learned to roll over. And then at about 6 months, they'll sit without support. Usually they can kind of sit themselves up at that point. Then after that, they will, somehow I left out crawl. Okay, we'll put crawl in there. Crawl after sit without support. They'll learn to crawl. And then after they crawl, they would stand and then they would walk. Now, my brother, for example, he didn't crawl. He just went from sitting on the floor to standing up and then walking. He was an early walker. Me, I crawled around. I was good with crawling. So there's a large variety, but we do have kind of a generalized scale of when they will do these things. The sequence has genetic beginnings with environmental influences. In other words, some cultures basically nurture, there are a lot of cultures that nurture the child being able to sit up and stand up and all of that more quickly, where they will start to, an African culture mentioned in your book, where they dig a hole, they put the baby in the hole. Here in the West, we would buy that little round pillow. You stick the baby in this little pillow to help them sit up and develop that. We're all in a big hurry to get these kids to walk and do these things. Whereas other cultures may carry that child until they're 2 years old. because it's not safe for them to be on the ground. It's not safe for them to be running around. And according to their culture and their environment, they need to be strapped down. Well, these kids are obviously the ones that are not able to walk and do all of this until they're like 2 years old. They're going to be starting slower. However, at 6 years old, these kids that are encouraged early are going to be at the same place as a 6-year-old that was not walking until they're 2. So usually it doesn't really matter that much, the timing. They'll get there. Okay, and this is what I just talked about. Some cultural practices, some are carried most of the time, some encourage them to walk earlier. Swaddling is a common practice that can be restricted to infants. Back in the, I think it was like 1700s, I can't remember exactly the date, but in the early times, there's like a 6,000-year history of swaddling. And we talked about that when we talked about comforting and soothing with crying, right? That swaddling is a very old practice, but it is restrictive where they're not moving as much. It does not appear that swaddling in any way slows down their development. So I already pretty much talked about all this. Long-term effects tend to minimally impact gross motor development. Good enough, we're moving on. All right, fine motor development. Fine motor skills are being able to grasp things, being able to pick up this yummy drink. My fine motor skills, okay? Putting on some lip gloss, this is fine motor skill. So being able to use our opposable thumb correctly. Now, our newborn, anytime we put something in their hand, they're just gonna grab it, but they're gonna grab it like this. And you know, if you put your hand here, they will grab it like this, but mostly they're just grabbing it with their whole hand like this. As they grow and develop their fine motor skills, they're going to learn to move their opposable thumb and use it in a grasping manner. They will develop something that's called the pincher grasp. This is something that comes around 9 months of age, and this is when you have them sitting there and they have the Cheerios on the tray and they're learning to pick up that Cheerio or that little item, the rice cookie thing or whatever it is. They learn to get that little tiny thing and try to put it in their mouth. And usually they drop about half of them, they miss their mouth, you know, they make a complete mess. But that's how they develop that pincher grasp. That's when they learn to grasp with their finger and their thumb. This is the period of time when they, you know, about 9 months, this is when they're already starting to kind of crawl, they're getting a little bit mobile. And it's a very dangerous time for infants because they can start to pick up those little items. And what happens as soon as they pick them up, they're gonna try to put it in their mouth because these little critters, they always wanna put everything in their mouth. Here's a image of a infant. She is picking up this block with her hand. And what she's going to learn to do, she's grasping it, and pretty soon she's going to be able to transfer it from one hand to the other hand. That's also part of her fine motor development, being able to change it from hand to hand and grasp it and manipulate it with her fingers. All right, depth perception. So we're going to talk about vision for a minute here. Depth perception is achieved by having binocular vision. We have 2 eyes, their images are a little bit overlapping, and our brain has to translate all of that, and this is what creates our depth perception. This starts to come into play around 2 or 3 months. Interestingly, there is something called a visible cliff, and I'm going to put a link to the video in the description on this, and it will be on Canvas because I'm going to put a couple of different infant videos up for you. But I have one that shows an experiment with the visual cliff. The visual cliff is it looks like there's a big step down, but there's like this plexiglass thing over the top of it. A 16 to 14-month-old child will not cross over where it looks like there's a drop off. So I think I may have an image of it. So they won't go over what looks like a drop off, even though it's plexiglass and they can, or, you know, glass, and they can look down like, I don't think so. I'm not going over that unless mom or somebody really encourages them. But a newly mobile baby that is just starting to crawl around and stuff, they don't even pay attention. They just crawl right over that visual cliff. And they don't, and so we don't believe that they have the same type of depth perception. So here's a depiction of the visual cliff. This is an infant that is already got some depth perception going on, and she is like, no, man, I am not crossing that. And there is a platform here, a plexiglass platform, but she's not going to cross that. Whereas a younger infant that does not have that depth perception all figured out yet would cross over it. Intermodal perception. This is the idea where infants are able to start coordinating the different sensory information that they have. They can match things in their mouth to things they touch. So it's like, oh, I know that this is here and this is in my hands. They just start integrating all of these different things. They can match faces with voices. They can kind of know if this is coming from the man who's talking, if this is coming from the woman who's talking. So they start to be able to weave all of these different sensory information together. And we call that intermodal perception. All right, so that's it. I know I talked an awful lot. Sorry about that. I'm just trying to give you guys a good lecture best I can. So I just hope you guys enjoyed that. I hope that this is going to be useful to you. And I will put those extra links down in the description. Have a good day and talk to you later.